Good morning, dear students. Let's start our class with a silent prayer. How are you all? I hope all of you are doing great and safe. Are you familiar with the concept of algebraic expressions? You have already learned it in the previous class. So, can any one of you tell me an example for algebraic expression? Yes, this is an example, I agree. And this is an example of algebraic expression. What are the other terms that you have learned in relation with algebraic expression? Yes, you have learned factors, then terms, then coefficient. The three terms, right? So, by looking at this algebraic expression, can you tell me how many terms are there? Yes, there are two terms. And which are they? What is the first term? Yes, it's 4x square. What about the second term? It's negative 3xy. You should also take this negative. So these are the terms and there are two terms. And then what is the next term that you have learned? Yes, factors, right? So by looking at these terms, can you tell me which are the factors for this one? How many factors are there? 3, and they are 4, x and again x. Because it's x square, so we split it as x and x. Coming to the second term, how many factors are there? Yes, we have 3 factors and they are negative 3, x and y. And these constitute factors. Correct? Then you have learned one more term. What is that? Yes, it's coefficient. Correct? So, my question is, in this algebraic expression, what is the coefficient of x square? Coefficient of x square. What is that? Yes. So this is the term consisting of x square and the coefficient is 4. So the coefficient of x square is 4. So what about the coefficient of xy? Is it 3 or negative 3? Yes, it's negative 3 because the term is negative 3xy. So the coefficient will be negative 3. So this is the basic things that you have learned about algebraic expressions. I hope you understood this problem. Let's discuss one more question. First of all, is it an algebraic expression? Yes, it is. Good. And how many terms are there? Yes, there are 3 terms. And which are the terms? Yes. First one is 7x square and second, yes, negative 4xy and the third is 5. Correct. And what about the factors? Here, which are the factors? Yes, we have 3 factors. They are 7, x and again x. Because x square is split as x and x. What about the second term? Yes, there are also 3 factors. They are negative 4, x and y. What about this term? Yes, 5 is the factor of 5 itself. Okay. So we have discussed terms, factors, and the next is, yes, it's coefficients. So my question is, what is the coefficient of x square here? Yes, it's 7. Good. What about coefficient of xy? Yes, It's negative 4. Is this problem clear to you? Okay. Now let's discuss some new concepts. Here you can see a lot of algebraic expressions, right? Okay. So first of all, tell me how many terms are there in this algebraic expression? Yes, only one term, right? So this, yes, this is also one term. So here I am writing the number of terms. So here both of this have one term each. So here it is number of terms. So the second set, these are also algebraic expressions. And how many terms are there in this expression? Yes, 2. What about this? Yes, here also we have 2 terms. What about the third one? Yes, we have 3 terms. What about the fourth one? Yes, we have 3 terms and they are, yes, very good, x cubed, x square and x. So this is also 3. What about the next expression? Yes, it's 1. This is second term, third term and fourth term. So in total 4 terms. And the next one. Yes, first term, second term and third one. And this is 3 termed expression. And this is 10y and this is 4x square. These two are expressions with single term. So here also the number of terms will be 1. What about this one? Yes, this is the first term, second term. So in total 2 terms. And this, yes, x, y, z. So 3 terms. Now you can see there are various algebraic expressions consisting of single term, 2 terms, 3 terms and more than 3 terms. So it will be better if we give some name to these categories. That is expression with single term, expression with 2 terms, expression with 3 terms for convenience. So can you suggest any name for an algebraic expression with a single term? Okay, I will help you. Which is the word that corresponds to 1 or which indicates 1? There is actually a word named monomial. Mono means 1. So let's name the expressions with single term as monomial. Clear? So the expressions with single term, that is only one term, is called monomial. So which among these categories will be monomial then? Yes, this one, right? So this is also monomial. Okay. So next, what about expression with 2 terms? Mono means 1. So what will be the word for 2? Yes, it's bi. So it will be binomial. Good. So this expression, these 2 expressions are with 2 terms. So let's name this as binomial. So among this, there is one more binomial, that is this negative z plus 5. What about the expression with 3 terms? Yes, good. It's trinomial. So this is trinomial. This is also trinomial. And this is trinomial. And this is also trinomial. Clear? Then, what about an expression with 4 terms? Okay, actually we call it as a general. We call this by a general name, and that is, yes, it's polynomials. So always remember that an expression, an algebraic expression with one or more terms is generally known as polynomials. But we specifically call the expression with a single term to be monomial, two terms to be binomial, and three terms to be trinomial. And 4, 5 or 6 expression with 4 terms, 5 terms, 6 terms and so on will be generally named as polynomials. So this is actually types of polynomials. So tell me, which are the types of polynomial we have discussed now? Yes, it's monomial, binomial, trinomial and generally polynomial. Let's do another problem. All of you write down the problem in your notebook. So the question is, here I am going to write some expressions. You have to classify them as monomials, binomials, trinomials and polynomials. Okay, so I hope all of you write down the question, written the question, and now let's discuss which among these are monomials, binomials, trinomials and polynomials. So first of all tell me which among these are monomials. Yes, this is an expression with single term, correct? Then, yes, this one is a monomial. Then, yes, this is a monomial. Yes, this is a monomial. Then this. So these are the monomials we have. Correct. What about binomials? What is binomial? Yes, an expression with two terms. So this is not. Yes, this is an expression with two terms. So this is binomial. What about the next one? Yes, this is. So this is also a binomial. And yes, this is also a binomial. Then this is also a binomial. Clear, right? Okay. What about trinomials? Trinomial means an expression with three terms. So this is not, this is not, this is not. So this is the only trinomial we have. And what about the polynomials? Yes, the remaining. This is an expression with four terms. This is also four terms. This is also four. And this is also four. Don't think that an expression with only four terms is known as polynomials. An expression with more than four, if it consists of 5 terms, 8 terms, 10 terms, then also we name this as polynomial. In generally, all these are polynomials, but specifically there are names such as monomial, binomial, trinomial, and after that we call everything as polynomial. Clear? Okay. Now let's discuss another concept. You can see a box, right? So here, by analyzing this, we will develop a new concept. Okay. So first of all, look at the first column. Here, what is it actually? What is it? These column consisting of? Yes, it's all algebraic expressions. Good. And consider the first set. Here, what is the speciality of these two terms or these two expressions? Very good. Both of these have same variable. What is a variable? Yes, the letters we use x, y, a, b, and they are known as variables, and the numbers we use are known as numerals. Here you have 2x and negative 5x. Both of them have the same variable, that is x. Okay. And for the second one, what is the relation? Yes, good. Both of them have the same variable, that is a. Good. What about the third one? Yes. Here you have xy and here it is yx. So is it same or different? X into y and y into x. Is it same? Yes. 1 into 2 and 2 into 1 is same, correct? Similarly, x into y and y into x are similar. And the next one. Here what you can see? Yes, here also we have the same variable, that is x square. And here it's p square. So by analyzing this column, you can see that if we take two terms or two expressions, in both of them the variables are same. Here it is x, here it is a, here it is xy, and so on. And the difference is only with the coefficient, right? Okay, and this is the analysis that we done in the first part. Coming to the second column, what is the relation between these two? Yes, the relation is that both of them are expression, especially monomials, but yes, different variables, right? Here x and it is y. Also the coefficients are different. Here, yes, this is also different. It's y and it's y square. Here, it's x and there is no variable. It's a numeral. And here, we have x and x square. Here, yes, it's x and it's xy. Here it is only single variable and here we have two variables. So, these all constitute a set and these all constitute another set. So, my question is, they are similar, right? Because they follow a same pattern. So, what we can call these sets? This set is one example, this is another example, and so on. So, my question is, can you name these examples a common name? Okay. See, they are similar, right? Because they have x in common. Here, they have a in common. So, we use the term like. So, let's name this set as like terms. What about this set? Yes, if this is like terms, this will be unlike terms. Yes, so this is unlike terms. So then can you tell me how we divided this as like and unlike? Yes, the expression with common variable, same variable is said to be like terms and different variables is said to be unlike terms. I hope this is clear to you. Here you need to remember one more thing. The variable should be same if there is power. That must also be same for the like terms and may be different for the unlike terms. Here as you can see, it's 5x square and it's negative 9x square. Here see, here we have the same variable x and also the power is also same. No need to consider the coefficient, just look at the variables. Here as you can see in this example, the variable is same, right? Both of them have x as the variable, but look at the power. This is x with power 1 and this is power 2. So we cannot say that these are like terms. So like term must have same variable with same power. Then only we can call it as like term, otherwise it will be unlike terms. Let's now do a problem based on this. All of you write down the problem. question is, you have to write like terms and unlike terms for 4mn square. Okay. Then tell me here, what are the like terms corresponding to 4mn squared? Do you remember the condition for the like terms? Yes. The variables must be same, and if there is power, that must also be same. So if you need a like term for 4mn square, what will be the difference? Yes, the change is only for the coefficient. So you can write any number instead of 4, you will get a like term. So negative 5mn square is a like term, and 10mn square is a like term. Mn square is a like term, right? Because mn square means here it is 1. So all these are examples for like terms of 4mn square. And what about unlike terms? We can write any expression other than this one. If you write 4mn, this is unlike, right? Because here the power of n is 2. Here the power of n is 1. So that is different. And if you write 4m square, this is also unlike, because here the power is 1, here it is 2. And you can write extremely different number, that is 3xy, which is extremely different from this term. So this is also an unlike term. So you can write any number of like terms and unlike terms. The unlike terms can be written by changing the coefficients, and unlike terms is written by writing using any variable and in any way. So this is the answer for this question. Now let's write down some notes. So we are writing the notes of the concepts we have learned in this class. So monomial is expression with one term, binomial an expression with two terms, trinomial expression with three terms, only three terms, and polynomial is an expression with one or more terms. So always remember, polynomial is an expression with one or more terms. Okay, so this is the first concept we learned, and then we learned what are like terms and unlike terms. So can you tell me what is like term? Yes, terms that have the same variable with the same power. So terms that have the same variable with the same power is known as like term. And unlike terms are, yes, terms that do not have the same or that do not contain. So you can write terms that do not contain or do not have So these are the six concepts that we have learned in this class. Let's do two more problems. All of you write down the question. question is construct a polynomial with 4 or more terms, and the second question is write a like term and unlike term of 12. Here the first question, you have to construct a polynomial. So you know polynomial is, yes, an expression with 1 or more terms, but specifically they are given we need a polynomial with 4 or more. So you have to construct a polynomial or polynomials with 4 or more terms. So can you tell me one such polynomial? Yes, very simply, x plus y plus z plus k. This is an algebraic expression with 4 terms and this is a polynomial. And what about another polynomial? Yes, we can write numbers too, right? 2x square minus 3y square plus 5xy minus 8z square plus 9. This is a polynomial with 1, 2, 3, 4, 5 terms. So this is the answer for the first question. You can write any number of polynomials with 4 or more terms. Okay. So coming to the second question, you have to write like term, a like term and unlike term of 12. So tell me the like term of 12. Yes, we need the variable L and we can take any number. So negative 4L. We need only one, but I am asking you for one more. Yes, 2 by 5L. If it is fraction, there is no problem. Okay. And what about unlike term? Yes, it's simple. You can write x square. You can write 2L square. All these are unlike terms. I hope this problem is also clear to you. In short, we have discussed the concept, the types of polynomial such as monomial, binomial, trinomial and polynomial, and the next concept like terms and unlike terms. I hope all of you understood the concept and the problems we have discussed. Here you have 2 homework questions. All of you please write it down and do it by yourself. We will discuss the answers in the next class. Thank you and have a nice day.